All right, this is about take 3 on this on this slide. I don't know why I just keep stumbling over my words. All right, so yeah, so what I like I told you earlier on in the video, the cool thing about these rules and these shortcuts that we have now, these formulas, is that now we can do some of those same things that we did before, like find the equation of a tangent line, but now it'll be a lot more efficient, right? So if I'm trying to find the equation of the tangent line to this function, then remember that what we want to do is we want to first of all just find the slope of the tangent line, which is equal to the derivative, right? And it's at a certain point. And so in this case, our point is at 1, right? X equals 1. So the slope of my tangent line at 1 is going to be f primed at 1. So first of all, what we're going to do is find f primed. Okay, so we're going to use our formula here. And so power rule, if I take the derivative of x squared, I just get 2x. Now here's one that we haven't done yet. If I take the derivative of negative 4x, you might be thinking, well, what's the exponent? What do we multiply by, right? And because this is not a constant, right? There's actually an exponent there that's an invisible 1. So just do what we normally do with the 1. So we're going to take that 1 and multiply it by negative 4. So it's going to be negative 4. And then we're going to subtract 1 from that exponent. So if we do 1 minus 1, we get 0, right? So we get x to the 0 power, and x to the 0 power is equal to 1, right? Because anything to the 0 power is equal to 1. And so all we have is just that 4, okay? And it's going to be negative 4, of course, but yeah, the x goes away. So if you have, so let's generalize this. If you take the derivative of some number, some constant times x, you'll just get that constant, right? Because you'll get x to the 1 minus 1 power, which is x to the 0, and that x goes away, all right? Okay, so basically we just get that negative 4 here. All right, and so that's our derivative function. And so now it's real easy to plug in whatever we want, right? So this case, what we want to plug in is 1. And so we put a 1 in there, so we get 2 times 1 minus 4. And that's going to be 2 minus 4, which is negative 2. So we just found f primed of 1 is negative 2. In other words, that's the slope of the tangent line at x equals 1, right? And so now we have the slope of the tangent line. So now all we need to use our point slope formula is a point. And we might as well use, and we actually must use the point where x equals 1, because that's the point on the line that we're going to have the tangent line to, right? So it has to go through that point. And so we know we're going to put in a 1 here for x, okay, because that's 1. We know we're going to put a negative 2 in here for m, because that's the slope that we just found. But what are we going to put in for y? And that's where we can easily find any output, because we have a function here, right? So basically what I want to do is I want to find f of 1, right? So I'm just going to do this original function, not the derivative. I want to find the original y coordinate of the point where x equals 1. And so I'm going to do 1 squared minus 4 times 1 plus 6. Okay, so I'm just putting a 1 in here and a 1 in here. And so what will happen is we'll get 1 minus 4 plus 6, and that equals 3. Okay, so f of 1 is 3, or in other words, 1 comma 3 is the point on that line where I want my tangent line to go through. Okay, and so that's what we'll put in for y1 is 3. And so what we'll get is y minus 3 equals negative 2 times, and I put this, this 1 should go right here, right? All right, so then I'll get x minus 1. All right, so that's the slope of our line. You can leave it like that. Just to show you, if you wanted to put it in slope-intercept form, it would be negative 2x plus 2. Then we'd add 3 to both sides, and so we get y equals negative 2x plus 5, right? So that would be a slope-intercept form of that same line. You don't have to do both of those. You can just show me one or the other, and point-slope form is probably the easiest way to go. All right, so that's how we find the equation of a tangent line. So we just use our shortcuts to find the derivative function. and then we plug in our x value and find the slope of the tangent line at that point, right? Find the derivative at that point. And then we also have to, at some point, you can do this at the beginning if you want to, but we have to plug in our point into the original function as well to find our y value there. And so once we find our y value, then we have all the pieces we need to plug into point slope form. Or you can plug it into y equals mx plus b and find your b that way too, if that's the way you like doing it. All right, so let's see. So let's do one kind of together. So we'll break this up, and but let me have you. I'll have you. Yeah, kind of drive the bus on this one. So try this one out. So what I want you to do first is let's find the derivative function. Okay. So go ahead and find f primed. All right, good. So if you got f primed of x equals 6x, well done. That's perfect. So now what I want you to do is I want you to plug in our x value. Okay, so I want you to find actually f primed at 2. So we can find the slope at that point, right, which will give us the slope of the tangent line. All right, so if you got 12, good job. So that's the slope of our tangent line at x equals 2. Okay. All right. So next, let's find the actual value of the y value at x equals 2. Okay. So we're going to use this function, and you're gonna plug in our input value that they give us, our x value, and then you're going to find the y value. Okay. So in other words, find f of 2. All right, so if you got f of 2 is 1, well done. All right, so now what I want you to do is plug those into point slope form. So now we have everything we need, right? We have our x value, we have the slope of our tangent line at that point, and we have our y value at that point. And so plug all those in and get me the equation of the tangent line. All right, so if you got this, y minus 1 equals 12 times the quantity of x minus 2, then yeah, you did well. That's it. Okay, and so and remember this, we got the 1 from here, that's our y value. We got the 12 from here, that's the slope of our tangent line, and then we got our x value from here. That was our given x value. All right, so yeah, it could come with questions tomorrow in class. If any of this didn't make sense, definitely ask me sometime before class, during the Kahoot, or right after the Kahoot when we have some time to discuss, and I'll be happy to yeah, answer your question or give you more examples or help you out in any way I can. So be ready to practice on this tomorrow, and or whenever, depending on when you're watching this for our next class, and we'll have a lot of fun.